Hello everyone, and welcome to this video on solving quadratic equations using the quadratic formula. So in this video I will introduce you to the quadratic formula, and then I have several examples on how we're going to use this special formula to find the solutions of a quadratic equation. Now if you've been watching me do these videos on solving quadratic equations, right? I had one on solving using the square root property, and then one after that on solving a quadratic equation by completing the square. If you know how to complete the square, if you know how to solve a quadratic equation by completing the square, you're good to solve any quadratic equation, right? Even this quadratic formula, you will see in a second, actually derives from that method of completing the square. So if you know how to solve by completing the square, you should be good to go. But of course this is also very nice. It's just something you can memorize to make solving a quadratic equation relatively quick and simple. So let me begin by starting off just explaining the derivation of the quadratic formula. Alright, so again, this is used for any quadratic equation. So here I'm going to write a quadratic equation in what's called standard form. And that's the following. I have some number a. Alright, so lowercase a is a number, a constant, times my variable x will be the variable here squared, plus, and then a term with x to the first power, with little b, a number, times x to the first power. Then a third term with x to the 0 power, or no x in it, just a constant, little c. So I have my quadratic polynomial in descending order, right? You have the second power term, then the first power term, then no power of x. Quadratic polynomial in descending order on one side equals 0 on the other. And as I mentioned, a, b, and c, so little a, b, and c, are real numbers. And of course the little a can't be 0, because if it were 0, then it wouldn't be a quadratic equation anymore, right? Because if a were 0, this term would be gone, and then it would be a linear equation, right, with x to the first power as the highest. All right. So what I'm going to do is, starting with this this is representing any quadratic equation, right? Any equation that's quadratic can be written like this. So starting with this, I'm going to go through and solve for x. I'm going to find the solutions to this equation by completing the square, that completing the square method from my previous video. Alright, so how did that go? Well, in order to complete the square, remember the lead coefficient on the coefficient on the x squared term needed to be 1. So if this a is not 1, what do? Well, we need to divide by a. Right, so I'm going to divide by a on both sides. Okay. So this first term, the a's would cancel, leaving me with the 1x squared, like I want when I'm trying to complete the square, plus this next term, I'd have b divided by a times x. So the fraction b divided by a, and I can divide by a here because a is not 0, we're saying over here. So we can divide by a, just pointing that out. So b divided by a times x, and then plus, and then this last term on this side, c divided by a, right? The fraction c over a. and this is equal to, and then 0 divided by a, right? 0 divided by a non-zero number is still 0. Right. So now I have what I want in front of the x squared if I'm going to be completing the square, right? The coefficient of 1. Then when you're completing the square, remember the only two terms that you started with to complete the square were the variable terms, the x squared term and the x to the first term. So I don't need this plus c over a fraction here. So I'm going to subtract that from both sides. So subtract c over a, and I do that from both sides. And so now on the left side I have x squared plus this, b over a fraction times x to the first. And because I'm going to be completing the square, I'm going to leave a little space for the expression. We're going to add a term to this so that I have a perfect square trinomial, right? 3 terms that can be written as a perfect square. Right? So I'm going to leave a little space, and then 0 minus c over a will just be minus or negative c over a. Right. Now remember how to complete the square. I have 1x squared plus and then some number times x. That number is b over a. So remember, for the completing the square part, you take the number times the x to the first, right, b over a. And then I'm going to cut this in half, divide it by 2, but that's going to look ugly. If I have b over a and then divided by 2, I'd have 2 fraction bars. It would look a little nasty. But remember, dividing by 2 is the same thing as multiplying by a half. So I can write times a half instead. And then when you multiply fractions, you just multiply the numerators. B times 1 is b. Multiply the denominators. A times 2 is 2 times a, or 2a. Remember, so you take that number that's multiplied by the first power, right? Then you cut it in half, and then you square that, right? b over 2a, you take that number and square it. Well, b squared would be the numerator, and then 2a to the second power, that's 2a times 2a, that'd be 4a squared in the denominator. This is the number right here. This is the number that gets added to do what they say, complete the square. Alright, so on this side I'm going to add this, b squared divided by 4a squared, and I do the same to the other side. I'm going to add b squared divided by 4a squared. Okay. Now the whole reason for doing this, right? Remember completing the square. When you add this third number on, this third term, you create a perfect square trinomial. Alright, so this expression here should be able to be factored now as a perfect square, the same factor twice. Alright, so it's going to be some factor to the second power, right? Something squared. And that factor is made up of, the variable x plus whatever half of that number times the first power term was. So what was half of that b over a? Well, that was b over 2a. Alright, and if you double check, it's a lot of letters, I know. Just bear with me here. We'll get to a nice place at the end of this. But if you were to take x plus, b over 2a and multiply it again by x plus b over 2a and, do all the foiling and then combine any like terms, you would see that this is indeed equal to x squared plus b over ax plus b squared over 4a squared. Alright, this is equal to, now on this other side, I have 2 fractions that I'm adding, right? Negative c over a plus and then b squared over 4a squared. When you're adding fractions, right, you need to have a common denominator. Well, this denominator is 4 times a squared, so it has an a already. So this other denominator with just a, it needs a 4, right, and another a, right? There's a to the first. This has a squared. So I would multiply this first fraction in the numerator and denominator by 4a over 4a. Alright? And then I would have the same denominator, right? They'd both have a denominator of 4a squared, so that's going to be the denominator of their sum, right? Common denominator, six around when you add. And then you combine the numerators. So this first numerator would be negative c times 4a, or negative 4ac if you put it in alphabetical order, right? Numerical order. So there's negative 4ac, and then plus b squared. Now you can write that, negative 4ac, then plus b squared in the numerator here. But very often you're going to see this written where the positive term is first, the term with the positive coefficient. So the positive b squared is usually written first, and then the other numerator that you're adding, the negative 4ac, is written second. Alright, so the sum of these two fractions here is b squared minus 4ac, all in the numerator, divided by, and then 4 times a squared in the denominator. And now I have an equation where I can use that square root property to help me solve. Alright, this is some expression squared equals some number. Remember, a, b, and c are all numbers. Alright, the only thing here that's a variable is x. So I have a variable in a square, and no variables, no x's outside that square. So this can be solved using the square root property. Alright, so by that square root property, alright, now I know I've mentioned in prior videos that I do like to split them up, but just for the sake of writing here and less writing, I'll condense it with the plus or minus symbol. By the square root property, the value of this base, this x plus b over 2a under the square, the value of that x plus b over 2a could be equal to either the positive square root or right, the negative, so plus or minus. Right? This x plus ba could also be the negative square root of this number on the other side of this fraction b squared minus 4ac in the numerator divided by 4a squared in the denominator. All right. And then we can actually simplify this a tad. This is plus or minus. I take the square root of the numerator, right? The square root of b squared minus 4ac, and then divided by, right? Make sure this division sign is not in the symbol anymore. And then the square root of 4a squared, well, the square root of 4 is 2, and the square root of a squared would technically be the absolute value of a. But we can always set up, if I go back to the original equation, you can always make it so that the lead coefficient is positive. If it is a negative number to start with, you can just multiply both sides by a negative number, and then you'll have an equivalent quadratic equation with a positive lead coefficient. So we can set these up to where we can assume that a is positive here and say that the square root of a squared is simply a instead of the absolute value of a, right? Because remember, this square root symbol means, give me the non-negative square root. All right, so this x plus b over 2a is either positive or negative. This fraction here, the square root of b squared minus 4ac, this all in the numerator, then divided by, and then in the denominator just 2a. All right, and then finally, to get x alone, I know this is a lot, right? Lots of letters, lots of crazy math going on, but this is the most important part to remember here at the end. I'm gonna solve for x, get x alone. I'd be subtracting this fraction, getting rid of this b over 2a and doing it to both sides. So on the left side I have x equals, and then over here, look at, I'm adding these two fractions. There's negative b over 2a plus this crazy fraction, and negative b over 2a minus this fraction as well. But notice they both have the same denominator. They both have the same denominator of 2a, so when I'm adding them or subtracting them, they can go together. They have the same denominator, and that denominator will be the denominator of the sum or the difference. So they both have a denominator of 2a. That's going to be the denominator of the final result when you combine them. And then you combine the numerators. This fraction's numerator is negative b, or the opposite of b, and then you have one with the plus, and then one with the minus. The other numerator is the square root of b squared minus 4ac, right? And that b squared minus 4ac is again all underneath the square root. That is the radicand of this radical symbol. And here are your solutions. All right, x is alone, and there's a nice description of the solutions to the equation I started with in that standard form, this ax squared plus bx plus c equals 0. And what I have in this circle down here, the x equals negative b plus or minus, one with the plus, one with the minus. This is two solutions here. The square root of b squared minus 4 times a times c, and then all of that, right, everything up there divided by 2 times a. This is called the quadratic formula. All right, and I'm going to write this out a lot in this video, and I would recommend you write it out a lot as well as you go through solving quadratic equations to try to get to memorizing this. All right. So, I mean, if you remember how to solve by completing the square, great. But if you memorize this and use it, it'll make solving quadratic equations very quick and easy. So let me just put out one more little tip here. Remember how I started the equation in standard form? This is how you have to have the equation you're looking at. You have to have it look this way. All right. If you're trying to solve a quadratic equation and it doesn't look like this, ax squared plus bx plus c equals 0, right? Everything on one side, no parentheses, equals 0. If it doesn't look like that, you cannot use this formula. The equation has to start off in standard form, or you got to make it look like, move some terms around, make it look like in standard form, and then you can use the quadratic formula. All right, so that's a note I'll put up here. All right, the big, very important. All right, the equation must be in standard form. That's that, again, everything on one side. A times x squared plus b times x, sorry about that little blob there, that's a times x squared plus b times x plus c equals 0, right? No parentheses over here, it's just a number times x to the second, the variable to the second, plus a number times the variable to the first, plus another number. That's it. No parentheses or nothing. Equals 0 on the other side. The equation must be in standard form in order for you to use the quadratic formula. Yeah, sorry, I'm a little off page here. Sorry about that, a little blob. In order for you to use the quadratic formula. All right. This is huge. All right, you must remember this. You cannot just jump into using the quadratic formula right away. All right, so I'm gonna, like I said, I'm gonna be writing this formula out here a lot. I'm gonna write it for every example, and as I said, I would recommend you write it out too as you're working through examples of solving quadratics, and that way, hopefully, after lots of repetition, you'll get to memorizing it, and it'll make solving your quadratic equations that much quicker, that much easier. Alright, so get this in your head. Right, it's got to be in standard form first. Alright, so I have several examples now of where we're going to use this, and this is really for the rest of the video. And I have several examples where we have equations that maybe don't start off looking like this, but we can eventually end up writing them in standard form and then using the quadratic formula. And of course, simplifying afterwards. Right? Simplify the radicals, simplify fractions, etc. Okay, so for each of these, the rest of the examples in this video, I have solved the equation using the quadratic formula. All right, so this is in standard form, this first example. It has to be that way to start. 2 times x squared, right? A number times the variable to the second plus the next term, a number, negative 3, times x to the first, then plus, and then your last term, another number, plus this negative 9 here. Ax squared plus bx plus c equals 0. So I'll identify the coefficients, right? That lowercase a, right, this is the coefficient of the squared variable. So the coefficient of x squared is, positive 2. Lowercase b, right, this is the coefficient of the first power, x to the first power. Not 3, but negative 3. Remember, you can write this as plus negative 3x. The negative sign is part of the term. So b is negative 3. And then the lowercase c is the constant term, right? The term that doesn't have a variable on it. That's the negative 9, not just 9, right? This is, again, you can write this as plus negative 9, plus c. All right, so I identify the coefficients. And then since it's in standard form, I can jump to the quadratic formula. Now I'm going to just put QF for quadratic formula and say, oh, I know what the solutions of this equation are. The solutions are x equals, and I'll write out the formula here. Right? Remember, it's the opposite of, in the numerator, we have the opposite of b. Then you have one solution with the plus, one solution with the minus. So this is, again, 2 solutions I'm getting here. The square root, make it nice and long there. And then under the square root, we have b squared minus 4 times a times c. All right, all under the square root. And then everything I just wrote is all in the numerator. All of that. Make a nice big long division bar underneath, divided by 2 times a. All right, and we're going to substitute. All right, so I'm going to pop those numbers in. So our solutions to this equation are the following. X equals, the opposite of, and then I like to put parentheses around anything I replace, right? I'm replacing b with the number negative 3. So I have negative, the opposite of, negative sign, and then b is replaced by negative 3. And we have one solution with the plus, one solution with the minus, and the square root of b squared, right? So negative 3 squared, then minus 4 times, a, again replacing a with 2, times c replaced by negative 9. And again, keep extending the square root symbol, right? All of that's under the square root. And then all of this, every single thing that I just wrote, is in the numerator. And then in the denominator, 2 times a, right? 2 times 2. And then, of course, simplify and check your solutions, right? So, of course, we simplify this. Simplify, I'll do the simplification first. So you simplify any products, any radicals, any fractions, right? This is a big fraction. You have a numerator and a denominator. So that numerator and denominator at the end, right, should have no common factors. You have a radical, right? So remember, when you simplify a square root, the radicand, the number underneath, shouldn't have any square roots other than perfect squares other than 1 that go into it evenly. Okay. All right, so let's keep this going. We have x equals, well, what's the opposite of negative 3? That's positive 3. Then again, one with the plus, one with the minus. Then this, negative 3 squared is positive 9, right? Negative 3 times negative 3, positive 9. And then here we have negative 4 times 2 is negative 8. But then we're multiplying negative 8 by negative 9. All right, so negative 8 times negative 9 will be positive 72. And we'll simplify that in a second. And then down in the, and then big bar, right, big division bar, and then down in the denominator, 2 times 2 is 4. All right, so we have 3 plus or minus the square root 9 plus 72 is 81. And ooh, that's a nice perfect square, right? So I can simplify that even further. And again, all of that divided by 4. I'll go over the side here. So this is 3 plus or minus, and then the square root of, this is the non-negative square root of 81. That's 9, right? 9 squared is 81. All that divided by 4, right? So yeah, so like I said, I like to split them up eventually. So one solution is x equals 3 plus 9, and then divided by 4. Well, that's just 12, 3 plus 9, right, in the numerator, divided by 4, and simplify the fraction there. 4 goes into 12 3 times. So one possible solution is x equals 3. Or the other solution is, one with the minus up here. Instead of 3 plus 9 over 4, 3 minus 9, then divided by 4. All right, well, 3 minus 9 is negative 6, and then we have divided by 4, and 6 and 4 have a common factor of 2. This reduces to 3 halves, right? So negative 3 halves. So my other possible solution is negative 3 halves, or negative 1.5, negative 1.5. Now that everything's completely simplified, don't forget to check your solutions back in the original equation, right? Always back in the way it originally looked. All right, so let me pull that up. Here's the original equation. All right. Let's do this here. All right. So the original equation was this: 2x squared minus 3x minus 9, equals 0. And I can do one of these real quick, right? When x is 3, 3 squared is 9. 2 times 9 is 18. Then the 3 times 3 is 9 in the middle there. So you have 18 minus 9 is 9, and then minus 9 again is 0. So 3 works. And negative 3 halves should also work here. And if you want, you can also use your calculators if you want to do that to check. Let me take my negative 1.5, negative 3 halves. So everywhere there's an x, I'm going to see if this left side gives me 0. So I've got 2 times, and then instead of x, right, I've got negative 3 over 2 squared, right? 2 times x squared, 2 times negative 3 halves squared. Then minus, and then 3 times negative 3 halves, and then minus 9, and hopefully that gives me 0. And look at that, indeed it does. So negative 3 halves also works. So I'm going to put these in a box, right? These are both good solutions to my original equation. Wonderful. All right. So the steps are the following. You put your equation in standard form, right? Everything on one side, 0 on the other, no parentheses. Put it in descending order, right? So you can then identify the a, b, and c, the coefficient of the square, the coefficient of the first power term, and then the constant coefficient. Then punch these in, replace all the variables a, b, and c in the quadratic formula, which hopefully you'll have memorized at some point. And then simplify the radicals, simplify the fractions, if any, and get your simplified possible solutions, and then check those solutions back in the original equation, see if they work, see which solutions are valid. Wonderful. All right, so that's all I'm doing. I'm doing those same exact steps for the rest of these examples. All right. So my next example, I am asked to solve again, find what could I replace x with to make this true. I have a quadratic equation, right? The highest power is squared. 2x squared plus 7x equals 4. Notice that this is not in that standard form. All right. And since it's not in standard form, I cannot use the quadratic formula. I can't use, again, I'm using just QF here for, I can't use the quadratic formula. So I have to put it in standard form. Now I've already got the ax squared plus the bx on the left side. I just need the 4 over there, right? So to get rid of that 4 on the right side, I'd be subtracting 4, right, from both sides. Make that into 0. I want everything on one side, 0 on the other. So on the left side, I now have, in descending order, right, the highest power, then the next highest power, and so on, 2x squared plus 7x, and then minus 4 equals 0. Now I have an equation that is in standard form, that ax squared plus bx plus c equals 0. So now I can use the quadratic formula. Alright, so what is that? I'm going to write it again. Here's the quadratic formula. Now, this equation has the following solutions that look like this. The solutions will be x equals the opposite of b plus or minus. So again, one with the plus, one with the minus. There's two solutions here. The square root, nice big square root. And then the radicand is b squared minus 4 times a times c, right, all in the radical. And then all of this is in the numerator. Nice big division bar, and the denominator of 2 times a. Alright, so I make the replacements. Well, first let me identify the coefficients. Right? So the little a here, the value of a is the coefficient of the square, is 2, positive 2. The lowercase b, the value of b, is the coefficient of x to the first, positive 7. And the value of c is the coefficient of the constant term without x, and that's negative 4. Right? Don't forget the negatives. Alright, so I'll make these replacements. So we have our solutions to this equation look like the following. X can be replaced by the opposite of b. Well, that's just negative 7. Right, the opposite of b, negative 7. Plus, one with the plus, one with the minus. Square root of 7 squared minus 4 times 2 times negative 4. Right, all under the square root. 4 times a times c. And then all of that divided by 2 times a. Right? Then we simplify. Okay. So the first term up in the numerator is still just negative 7 plus or minus. Then we have the square root. I'm just going to say what it is here. 7 squared is 49. I'll write it out one at a time here. 49. And then this, you have negative 4, the next term, the next product, you have negative 4 times positive 2, that'd be negative 8. But then negative 8 times negative 4 would be positive 32. All right, 8 times 4. And then all this divided by 4, all right, 2 times 2 in the denominator. Okay, so we have negative 7 plus or minus the square root of, well, 49 plus 32 is again 81, right? I know that these first two examples have had 81 as the radicand. That's not always going to happen, trust me. We'll see examples after this where that doesn't happen. And then we have all that divided by 4. But the square root of 81, that's not a simplified radical, right? 81 is a perfect square. So I have negative 7 plus or minus a square root of 81. The principal square root is 9, right? And all this, divided by 4. And then here's where I like to split up, right? These are actually numbers I can figure out. There's no square roots anymore and whatnot. So my solutions, one of them is, negative 7 plus 9 divided by 4. Well, negative 7 plus 9 is, positive 2 divided by 4. And that reduces to a half. Right, so x equals 1/2 is a possible solution. Or, and then the one with the minus, x equals negative 7 minus 9 in the numerator, the minus one, divided by 4. Well, negative 7 minus 9 is negative 16, divided by 4 would be negative 4, right? All right. So again, check these, right? Do not forget to check your solutions back in the original equation. Now the original equation looked like this. All right, 2x squared plus 7x equals 4. Try the half. I can do the half out loud pretty quickly. Put in a half for x. 1/2 squared is 1/4. 2 times 1/4 would reduce to 1/2. That'd be 2/4, 1/2. And then 7 times a half would be 7 halves. 1/2 plus 7 halves is 8 halves. 8 divided by 2 is indeed 4. 1/2 works, and trust me, -4 will also work. That's -4 squared is positive 16. 2 times 16 is 32. 7 times -4 is -28, and 32 plus -28, or 32 minus 28, is indeed 4. So both of those work. I'm going to put them both in a little box here, circle them. They're valid solutions to my original equation. They make it true. Great. So again, the same steps were followed. Put it in standard form. I identified the A, B, and C. I put those into the quadratic formula and simplified, and then of course, checked the solutions. Wonderful. Here's another one. All right. And it'll get a little more complicated in the next couple of examples, you'll see. So this one, I've got 4z squared. Now the variable's z instead of x, but it's no different, right? If you want to change the z's into x's, be my guest, but I'm going to keep it as z. 4z squared plus 1 equals 8z. This is not in the standard form, right? I would want all the terms on the one side and 0 on the other, and in descending order, right? With z squared first, then z of the first, and then no z. So get it in standard form. The first thing I would be doing is I'll take away 8z from both sides. All right, so on the left, if I write all the terms in descending order, we'd have 4z squared plus, and then the -8z to the first, and then the plus 1 equals 0 on the right side. Now we have this quadratic equation in standard form. We can use the quadratic formula, which I will write yet again. I'm going to do it I would recommend you also write it a lot to get the hang of it, get it down, get it in your memory. All right. The quadratic formula sorry, not x, this is z this time, right? So the solutions to this equation will look like the following. Z equals the opposite of b, then one with the plus, one with the minus, plus or minus the square root of b squared minus 4 times a times c, all inside the square root, and then all of that, everything I wrote is in the numerator, and the denominator 2 times a. All right, let's identify those coefficients. What's the value of a? All right, again, that's the coefficient of the squared term when it's in standard form. That's the 4, positive 4. The b is the coefficient of the first powered term, the linear term in standard form. That would be the -8, right, times the z of the first. Don't forget the negative. And then the value of c is the value of the constant term, right, the term without the z in it. In standard form, that'd be this positive 1. All right. So I plug those into the formula, and we're getting the following, right? So the solutions to this equation look like this. Z equals the opposite, right? You got negative of b. Well, that's the opposite of -8. That's going to end up being positive 8, plus or minus the square root of b squared, right? So -8 squared. -8 times -8, that'll be positive 64, minus 4 times a, 4 times 4, times c, right? Times 1, all into the square root, and then everything I just wrote is in the numerator, divided by 2 times a, divided by 2 times 4. All right. So I put it in standard form, identified the coefficients, A, B, and C, plugged them in the formula. Now we simplify. Alright, so the values of z, the opposite of negative 8 is, positive 8. We have plus or minus the square root of, negative 8 to the second power is 64. And I hope you understand that if our coefficients, A, B, and C are real numbers, when you do b squared, that's going to be a non-negative number, right? Whenever you take a real number and square it, you're going to end up with a non-negative number. So that's non-negative 64. And then we have minus 4 times 4 times 1. 4 times 4 times 1 is just 16. So minus, but you have a minus there. So minus 16, all in the square root. And then all that divided by 8. All right, 2 times 4. So that's 8 plus or minus the square root. Now 64 minus 16 would be 58. I'm sorry, 48. Blech. 48. All right. And then all this divided by 8. The square root of 48 is not a simplified radical, because there are perfect squares other than 1 that go into 48. And in fact, 48 is 16 times 3. So I could break this up into the square root of 16 times the square root of 3, which would be 4 times the square root of 3. Right? So this is 8 plus or minus the square root of 48 is equivalent to 4 times the square root of 3. Right? The square root of 16 times the square root of 3, all divided by 8. Alright, so I've simplified the radical. Cool. But now I got to simplify this fraction. Right, so remember, the fraction's not simplified unless the numerator and denominator have no common factor. But if you look at the numerator, these two terms, the 8 plus 4 times the square root of 3, or even 8 minus 4 times the square root of 3, they both have a common factor of 4. Right? This is 4 times the square root of 3, and 8 is 4 times 2. So I can pull out a common factor of 4, and when I remove a factor of 4, what's left over would be 2 plus the square root of 3, or 2 minus the square root of 3, right? So 2 plus or minus the square root of 3 left over in parentheses. And then you have 8 in the denominator still. And then you have a common factor in the numerator and denominator, right? The 4 goes into 4 once, and when you divide out the 4, 4 goes into 8 twice, so you have a factor of 2 left over in the denominator. So I have when I remove the factor of 4 up there, there's 2 plus the square root of 3, 2 minus the square root of 3 in the numerator, divided by, and then just 2 in the denominator. And you can leave it like this if you wish. I could say z is equal to these guys. That's totally simplified, and I don't know what the square root of 3 is, so I can't do what I did in the previous examples, where I add these and then divide by 2 and get a nice number, or subtract these and then divide by 2 and get a nice number. You could also just write them out separately, right? Say z is equal to 2 plus the square root of 3, then divided by 2, or z is equal to 2 minus the square root of 3, then divided by 2, and simplify it that way. Or the numerator has multiple terms, so you can divide each term by the denominator, right? That's almost like reversing adding fractions or subtracting fractions. So this first term, 2 divided by 2, that's 1. And then you have plus or minus, and then the square root of 3 divided by 2. I gotta make sure the division sign's big enough so you know that the 2 is not in the square root. These are good as well. I mean, all these are the same numbers. All these, in all 3 of these bubbles I put in here, represent the same numbers. Oh yeah, I'm kind of circling them prematurely. Don't forget we need to check. Alright, so I'm going to do this with the calculator. Alright, I mean, you can do it by hand. It's just a little more tedious because of the square roots involved and whatnot. Okay, so what I'm going to do on my calculator here is I'm going to enter one of these numbers and we'll check it. So, how about 2 plus the square root of 3 in the numerator, right? So in parentheses. Then in the denominator divided by 2. So one of the solutions is 1.866025, right? I'm going to store this, right? There's a feature in a lot of calculators where you can store a previous answer as a letter. I'm actually going to store it as z. I'm going to store this as, and then use the letter z, the alpha feature. So now every time I enter the letter z in my calculator, that's the number that pops up, 2 plus the square root of 3, and then divided by 2. And let's see if it actually makes the original equation true. So I'm going to plug it into the left expression. So 4 times alpha z squared, and then plus 1. Okay, and I get this number, 14.928203323. Now hopefully when I plug it into the other side, right, the expression on the other side of the equal sign, I get the same number back. So let's try 8 times this z, 8 times this 2 plus the square root of 3, all divided by 2. So 8 times z, and look at that, it is indeed the same number. So 2 plus the square root of 3 divided by 2 is a good solution, makes this a true statement. And you can also double check that 2 minus the square root of 3 divided by 2 also works, and I leave that to you. So both of them are good, I promise. Okay, so far, we've seen a few examples where the solutions ended up being rational numbers. Here, the solutions, you have irrational numbers involved, right? The square root of 3 is one of those irrational numbers. We've had a couple where the equation doesn't start off in standard form. Well, I'm going to keep going with those examples, but these ones are going to be a little trickier looking because they're rational equations. They have fractions in them, and they don't look like a quadratic. All right, so here's an example of an equation like that. So I'm asked to solve this, using the quadratic formula. All right, it's actually in this exercise set I'm looking at where they're asking me to solve this thing using the quadratic formula. But this does not look like a quadratic equation at all to me right now. Right, there is no w squared anywhere. All right, but there is this fraction, and if you recall, I did a video a while back solving equations with rational expressions with fractions in them. And the first thing I did was find the least common denominator of those fractions. Well, the only denominator here other than 1, right, 4w over 1, 20 over 1, is w. So what I would do is I'd multiply both sides by the LCD, the least common denominator, multiply both sides by w. And I guess before I do that as well, I'm going to make sure that I note to myself that, and hopefully you see it too, the value of w can't be 0, right? Remember, you can't have a denominator of 0 anytime throughout a problem because dividing by 0 is undefined. So I'm going to point that out to myself as well. So note, as long as w is not 0, I can do the following. I'm going to multiply both sides by w, right, by the LCD. So I take 4w plus 25 divided by w, and then multiply this by the LCD, right? Multiply it by w. Now there's going to be distributing involved here because there are multiple terms. There are 2 terms on this side. Equals, and then take the other side, 20, and also multiply it by w. Right? And again, it would make sense to say that w is not 0, right? Because if w were 0, that'd be awful. Because if you multiply both sides by 0, that eliminates everything, and you don't have any information at all about the equation. All right, so let's see what happens when you do this. So the first term on the left side, you have w times 4w. That'd be 4 times w squared plus. Then when you multiply, now the whole reason for multiplying an equation both sides by the least common denominator is to get rid of the denominators, right? All the denominators should go into the LCD evenly. So when I multiply the w by the 25 over w, the w's will cancel and I'm left with the factor of 25 in the numerator. Right? So the left side becomes 4w squared plus 25 equals, and then the right side, when I multiply that by w, it's just simply 20 times w. And now can you see how this is a quadratic equation now, right? There's w squared as the highest power here and no more fractions. But it's not in standard form, right, I cannot use the quadratic formula just yet. So what needs to happen next, right? I get everything to one side. I'll do it this way by taking away the 20w from both sides, and then we'll write it in standard form, descending order. I got 4 times w squared, then the minus 20w, then the positive 25, all right, equals 0. All right, now we're in standard form. Now we're in business. All right. Now that I'm in standard form, I identify those coefficients, the a, b, and c. Right? A is equal to the coefficient of the square. Right? W squared is a positive 4. B is the coefficient of w to the first. That would be negative 20. Don't forget the negative. And c is the coefficient of the constant term, right? Just a positive 25. Alright, and then I go and take these numbers and throw them into the quadratic formula. Alright, now that I'm in standard form, I can use it. Okay, so taking this down here, I've got the quadratic formula, QF. So I'm going to write it again. So the values of w this time, right, the variable is w. So the values of w that solve this equation will look like the following. The opposite of b plus or minus the square root of b squared minus 4 times a times c, all in the square root, and then all of this is in the numerator. Big bar, big division bar, and then divided by 2a. Alright, so I enter these numbers, the a, b, and c over here, the 4, the negative 20, and the 25. And we're getting our solutions. W equals the opposite of b, which is negative 20, so that'll become positive 20 in a second, plus with the one with the minus, square root of, and then b squared, right? So negative 20 squared minus 4 times a, which is 4 again, times c, all in the square root. And then all of this divided by 2 times a, or 2 times 4. And then, of course, we simplify. So the opposite of negative 20, 20, plus or minus the square root. Negative 20, but squared will be positive, right? Always non-negative when you square a real number. 400. And we have minus, negative 4 times 4 is negative 16, times 25 would be negative 400. Ooh, look at this. This is going to actually end up real nice for us. We haven't seen this yet. Alright, so I have 400 minus 400 in there. All that divided by, 2 times 4 is 8. So I have 20 plus or minus, this is 0. The square root of 0, which is just 0, divided by 8. So this means that I'm getting the same solution twice. 20 plus 0 and 20 minus 0 are the same number. They'll call this a repeated solution or a repeated root to this equation. And let's see what that number is. Right? We're getting w equals, and then notice I'm not going to split this up. I'm not going to write this as two different solutions. It's just simply 20 in the numerator both times. 20 plus 0, 20 minus 0. So just 20 divided by 8, which when you reduce it, they both have a common factor of 4. Right? That would be 5 halves. And that's it. All right, and again, this would be called a repeated root or a repeated solution, right? Because I'm getting the same solution 2 times. And let's check it out. All right, let me go back again to the original equation. Yeah, let's do this, right? So the original equation was this. W plus 4w plus 25 over w equals 20. And I'm saying w is 5 halves. Plug it in. 4 times 5 over 2 would be 20 over 2, which would be 10. So you get 10 for the first term, and then 25 divided by 5 halves. Well, remember what division means. Division is the same as multiplying by the reciprocal. So 25 divided by this number would be the same thing as 25 times 2/5, the reciprocal. And 25 times 2/5 would be 50 fifths, 50 over 5, or 10 again. You'd have 10 plus 10 equals 20. That is indeed true. Thumbs up. This is a valid solution, 5 halves. All right, and again, they would call it a repeated root or a repeated solution because of the fact that you had plus 0, minus 0. You know, you had the same solution twice. Wonderful. All right, so I have one more example like that. All right, where it starts off not looking like a quadratic, but through a simple multiplication, you'll see that it is equivalent to a quadratic equation. All right, so there's another one similar to that, right? We have 2 times x equals 8 minus 3 divided by x. Another one with a fraction. As with the last one, I'm going to point out, hey, x can't be 0 here, right? Because if x were 0, you'd be dividing by 0. You can't do that. And just like the last one, x is also the LCD, right? That is the only denominator other than 1. So the LCD is x. So in order to make this a nicer looking equation, I'm going to multiply both sides by the LCD. Right? So I'm going to multiply 2x on the left by x. And then on the right side, this entire, there are 2 terms over here, right? It's a difference. So we're going to be distributing when I multiply. I have 8 minus 3 over x, and that's getting multiplied by the LCD by x, and again there will be distributing that needs happening over there. And the whole reason for doing this multiplication by the LCD is to get rid of the denominators. Right? So on the left side, x times 2x, that's 2x squared, equals on the right side, 8 times x minus 3. Right, because again, this second term, the 3 over x, when I multiply that by x, the x's will cancel. Right, and x is not 0, so that's going to happen. Now I have a quadratic, but it's not in standard form. Right? Now I have a personal preference. I mentioned this earlier. I do like having the coefficient of x squared, my squared variable, being positive. So yes, you could subtract the 2x squared and it would be in standard form, right? Everything on one side, 0 on the other. But I prefer, me personally, again, I prefer having a positive lead coefficient. So what I'm going to do is I'm going to take away these terms. I'm going to subtract 8x from both sides and then add 3, right? Then I'll get rid of the negative 3 over there and add 3 to both sides. So that gives me this equation in standard form. Right, we have the 2x squared term, then we have the negative 8x term, then the positive 3 term equals, and then over here I got rid of everything, 0. Right, now I have an equation that's in standard form, and I'll identify the coefficients, right, that a, b, and c. All right, so the value of a, the coefficient of the square, is positive 2. The value of b is negative 8. The value of c is positive 3. And I go into the quadratic formula, which I will write again. I would again recommend writing it until you memorized it, until you got it down cold. Alright, so here's the quadratic formula again. So the solutions of this equation will look like this. X equals, the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all in the root. Then all of that I just wrote is in the numerator, divided by 2 times a. And I pop these numbers in for a, b, and c down here. Alright, so let's do that. And we're getting x equals the opposite of negative 8 plus or minus the square root of negative 8 squared minus 4 times 2 times 3, all under the root, and then all of that divided by the denominator of 2 times a, or 2 times 2. Now we simplify. All right, the opposite of negative 8, this first term in the numerator, that's positive 8, plus or minus the square root of negative 8 squared is positive 64. Then we have minus, negative 4 times 2 is negative 8, and negative 8 times 3 is negative 24, right? And then all of this divided by, 2 times 2 is 4. So we have 8 plus or minus the square root of 40, right? 64 minus 24. All of that divided by 4. The radical is not simplified, right? 40. 4 is a perfect square that goes into 40, right? You can write that as 4 times 10. So I can break this up to the square root of 4 times the square root of 10, or 2 times the square root of 10. So x equals 8 plus or minus the square root of 40 is equivalent to 2 times the square root of 10, and all that divided by 4. Now I've simplified the radical, but the fraction is not simplified. Look at the two terms in the numerator. They have a common factor of 2. Right? I can pull a 2 out of that. And if I do, you have a remaining, 2 times 4 is 8, plus or minus, and then this is 2 times, the square root of 10 would be left over. So I have 4 plus or minus the square root of 10 in parentheses after removing a factor of 2, divided by 4. And then, 2 goes into 2 once, 2 goes into 4 twice. You'd have a factor of 2 left over in the denominator. All right, so when it's all simplified, our solutions are the following. The numerator I have 1 times, so like just this 4 plus the square root of 10, or 4 minus the square root of 10. And then all that divided by 2 in the denominator. And there you go, you can leave it like this. This is totally simplified. Or you can actually split them up again, right? One is 4 plus the square root of 10 divided by 2, and one is 4 minus the square root of 10 divided by 2. Or divide each of these terms by 2, right? 4 divided by 2 would be 2, then plus or minus, and then the square root of 10 divided by 2 is just that, right? One is in a square root and one is not. So don't make that the square root of 5, right? This is not in a square root, so I can't divide these 10 and 2, right? Because one's in a root and one's not. So you could also leave it like this as well, right? But 2 solutions here within a rational number again. And then I know I've circled it. Let's check. All right, let's check. This was the original equation. 2x equals 8 minus 3 over x. And I'm going to go to my calculator, and I'll enter one of these numbers. You can enter it like this or like this. I'm going to do this one this time. So how about 2 plus then the square root of 10, and then outside that square root divided by 2. So one of these solutions is possible solutions is 3.58113883 blah, blah, blah. All right. So like I did before, I'm going to so I don't have to keep typing this out. I'm going to actually store this as the letter x. All right, these are variables x in here. So every time I type x, it's this number, right? 2 plus the square root of 10 divided by 2. All right, so I'll punch it into the left expression. So it's just 2 times x, giving me 7.16227766, so on. And then I'll plug it into the right expression of the on the right of the equal sign, and hopefully I get the same thing back. So 8 minus 3 divided by x. And it is indeed the same number, 7.16227766, so on. So 2 plus the square root of 10 over 2 is valid. That's the same as 4 plus the square root of 10, all divided by 2. And you would see that 2 minus the square root of 10 over 2 is also a good solution if you checked with the calculator. Or you could check it by hand if you want. A little more tedious that way, but you can still do it. All right, so far, I know it's a long one, sorry. Got one last example, because so far we've seen a couple of examples of equations where you ended up with some rational number solutions. Several examples like the last one with that square root of 10 involved. One of them had a square root of 3 involved. So we've seen some where there have been irrational number solutions. But there are going to be some where you have solutions that have an imaginary number in it, right? One of those pure imaginary numbers where you have a real number times that I, that square root of -1. So you're going to see those. That's going to happen when you end up taking the square root of a negative, right? Remember, the square root of a negative number you should be rewriting as a pure imaginary number, right? As a real number times I. So I have one last one here. It's nice, simple to start. I don't want anything nothing too crazy. It's in standard form already, right? Everything's on one side, zeros on the other, so I can use the quadratic formula right now. All right. Before I do that, let's identify the coefficients. All right. The value of a, the coefficient of z squared is, there's nothing there, but that means it's 1. The value of b is positive 2, the coefficient of z, right? And the value of c is the positive 26. All right. And the quadratic formula, right? The solutions of this equation will look like this: z equals, right, instead of x, right? Z now. The opposite of b plus or minus the square root, and then inside that square root, b squared minus 4 times a times c. And then everything I just wrote is in the numerator, big bar, and then divided by 2 times a. So I'm going to punch those numbers in, and here are the solutions. Z equals, the opposite of 2 plus or minus the square root of 2 squared minus 4 times 1 times 26, and all of that divided by 2 times 1. Now we simplify. First term up here is negative 2 plus or minus the square root. 2 squared is 4. All right. 4, then you have negative 4 times 1 times 26. That'd be negative 104. So that's 4 minus 104. So that's negative 100. And hopefully you recall, as I mentioned before, when you see the square root of a negative number, you please think immediately, I should rewrite that as a pure imaginary number, as the square root of the positive times I, right? Remember that I is that square root of negative 1, right? And whenever you see I squared, that it's the number that when squared gives you a negative. So we'll keep that in mind in a second here, and then all this divided by 2 times 1 is 2. So the square root of negative 100, the square root of negative 100, I am going to rewrite as a pure imaginary number. Right? So I have negative 2 plus or minus, and then the square root of negative 100 is the square root of 100, positive 100, that's a real number, times the imaginary unit I. And then all this, divided by 2, and what is this? Simplify the radicals, right? Square root of 100, the principal square root of 100 is 10. So this is negative 2 plus or minus, 10 times I. That's the square root of negative 100. It's 10I when totally simplified, and then divided by 2. And then you could factor the numerator or whatever. They both have a common factor of 2. But it's very easy to see that I can simplify these easily when I divide each one by 2, right? Take every term in the numerator, divide by 2, negative 2 divided by 2, negative 1, plus or minus, and then 10 times I divided by 2, well, 10 divided by 2 is 5, so you have 5I. Okay, so my solutions are negative 1 plus 5I, or negative 1 minus 5I. Right? Alright, now again, checking this would be a little trickier. Alright, checking these would be a little trickier. Now you could plug in, let's check negative 1 plus 5I. If you plug in negative 1 plus 5I, you'd have negative 1 plus 5I squared. So you'd have to take negative 1 plus 5I times negative 1 plus 5I and then FOIL. And remember, every time you see I squared, that's actually negative 1. And combine like terms and whatnot, and then you have negative 1 plus 5I here, distribute the 2, and you would see that you'd get 0 equals 0. They're going to work. Now I do also have a calculator that has the feature where I can enter I's, right? Again, I'll mention this one more time, like on a TI, this is 84 plus. If you hit the mode button, and there's a line where it says real and then A plus BI, if you click on the A plus BI part, you can actually enter imaginary numbers in your calculator. So if I want to test, is negative 1 plus 5I a good solution? Let's see, in parentheses, negative 1 plus 5, and then the I is above the decimal point on this. So I. There's negative 1 plus 5i, and then I'm squaring that, right? That's z squared plus 2 times, z, negative 1 plus 5i, and then plus 26, and hopefully that gives me 0, right? I'll get 0 equals 0, and oh, look at that, it is 0. So negative 1 plus 5i is a good solution, and you can do the same for negative 1 minus 5i. Check that out either by hand or with a calculator if you have one that's capable of putting in imaginary numbers. That's great. Alright, and that's the last example I have where I'm using the quadratic formula to solve an equation that can be written in the standard form of a quadratic equation, right? So that's the key, right? You write your equation in that standard form, that ax squared plus bx plus c equals 0. Identify the a, b, and c, plug them into the quadratic formula, right? The opposite of b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. And then once you've plugged in your numbers, simplify all the things that you see, all the products, all the addition, subtraction, simplify your radicals, and simplify the fraction. Write it as a completely simplified version of itself. And if you ever see a square root of a negative, like we did in this last example, the square root of a negative is one of those pure imaginary numbers. You should immediately write it as the square root of the positive times I, right? Write it as a real number times that imaginary unit I, please. Great. Oh, and of course, check your solutions. Wonderful. Alright, and as I like to say at the end of these videos, do the best you can to try and learn the material on your own before you go looking for help. I've found over the years that people who take the time and the effort to learn something on their own tend to remember that material for better and also remember it for longer and are more proud of themselves for it. So of course, read the material, right? Read through the author's examples, perhaps even try to work out the solutions to an author's examples before you see how the author did it themselves, and then compare your work to the author's and see if you can learn from some mistakes there. Obviously, do tons of exercises, practice problems, check solutions to those whenever they're made available. All right, practice makes progress. You can't get better at something unless you practice it. And just and don't give up on a problem after 1 or 2 attempts. Don't give up so easily. Very often there are several approaches that'll work for any particular math problem. So, if after several attempts at a problem you're still not getting it, you're still in trouble, still having trouble, maybe you should go back and read the material again, maybe even a 3rd time, because if you've been working on some problems, as you should, there's a good chance you have a better idea as to what the author is asking of you, what the author wants from you, what the author expects from you. So then when you go back and read it, again, or maybe even a 3rd time, you'll have a better idea as to what to look out for in the reading, what's important in the reading. And you'll probably catch some things also that you didn't catch the first time. That might, or maybe something will click that didn't click the first time, and you'll have this aha moment, and it'll make working on the problems that much easier. But if after that, if after several read-throughs of the material and several attempts at problems, you're still not getting it, you're still having trouble, it's not a sign of weakness whatsoever to ask for help. That is what people are there for, to help you. So ask a teacher, a tutor, a friend, someone in your class who knows the material and is willing to help. Look for supplemental materials online. There's tons of it out there. Look for videos online. There's loads of those too. Videos like this one, or plenty of other ones out there better than this one. I assure you they're out there and they're easy to find. Just keep at it. Stay persistent. Keep practicing. Don't give up. And above all, and I think this is the hardest thing for most people, stay positive about the subject. Stay positive about yourself, your own abilities. Believe in yourself even through your struggles and failures and mistakes. It's at those times when you struggle and fail and make mistakes. It's at those times when you can learn the most, and learn the most deeply. Because if you actually persist and make it through those and learn how to fix your mistakes, you're going to remember that material better and longer than someone who got it right the first time and just breezed through it and never gave it a second thought. They'll have forgotten how to do that a week later, maybe. It'll have been nothing to them. Whereas if you struggled and had to persevere and had to persist and push through and fix your mistakes, there was emotion attached to that. And there's a lot of learning going on when you have strong emotions about something. So stick to it. Stay persistent. Keep practicing. Stay positive above all. And don't give up. And I'm sure you'll get it. I just know it. And thank you very much for watching.